So this is the beginnings of the miniature gooseneck trailer project. So basically, I'm going to probably have like future plans. I'm thinking of having like some like maybe EMT, boom, EMT. You know what I mean? Because it would keep the electrical mojo going on, and I could just make that with a simple bender. And if I use like, I don't know, you could use like half-inch EMT, but honestly, half-inch EMT, it's kind of like not that thick, but if you kind of go up to maybe like an inch is probably better. And this is just regular EMT, you buy it at Home Depot. So you just cut it, and if you got a bender, you bend it, I guess. Or maybe you can cut and weld it. Maybe that'll be... Anyways, so basically what this is, it's an old electrical panel. If you actually look closely, you can see the tires will stay there as the, you know what I mean? So it's walking axle, or whatever you call it, walking beam. So this would be the beam. So I cut these beams out of just some like really thick steel. I was like, wow, I'm gonna use like some thick stuff because it doesn't really matter. But it's a thread rod that goes through it. So I just precisely drilled a hole, and I just made sure the distance was all equal. Because what I did on here, these are 3D printed wheels. So the 3D print, it's flexible here, so you can push on it. The thing is, they're actually quite a bit more stiff than I was kind of thinking, and especially in the cold, but they will start to bend if you really push on them, but they're extremely strong, or at least I'm predicting they will be. The center is a PETG hub, and it's two sides, so I just cut it in half, and I, just in this case, I was going to glue them together, but I was like, well, why would I even glue it? Because the hubs, like the black part, it fits so tight in the white part. I hit it with a mallet to get it in on both sides, and so I just put zip ties, you know what I mean? So I just put a bunch of zip ties, and I made sure they're really tight, and what that should do is just keep the hub together, but it's also held in with this bolt. So the walking beam, I welded, like this is the head of the bolt, I welded it. So, and then the bolt is pretty long-ish, so it goes all the way through, and I have skateboard bearings on each side, so there's two skateboard bearings per wheel. Skateboard bearings, in this case, I kind of messed up. I fudged up the design in CAD, or whatever, just in the Orca Slicer. So I tried to put like a blank, like in the software, I tried to put a blank, because the file originally wasn't meant for this application, obviously. So I tried to redo like a negative part of the skateboard bearing, and put it right up against the thing. But anyway, so somehow it messed up, so I had to manually, with a Dremel and a flat, like the top is flat or whatever, go in and Dremel in and around and try to make it bigger but keep the circle. So what ended up happening was I had to JB weld, and I just made sure the wheels were as true as I could get them while the JB weld was drying, and it actually turned out all right. So if you unscrew these bolts, like these two nuts, I mean, sorry, off the bolt, the whole tire will come off, so it's easy if you need a replacement, or if you get a, I was gonna say get a flat, but these tires are, they're obviously, if you look closely, they're airless, so they hold a lot of weight. I could probably stay in the back of this trailer, and because there's 4 of them here in this context, it won't even, like I'm 140 pounds-ish, and I'm standing in the back of it, oh, shit. And it doesn't even flex at all, so I probably even could have gotten away with not even doing all this and just did like 2 tires in total, but whatever, here we are with the design. And I guess if you hit a large bump, that's really it's gonna absorb the impact, but maybe when it's hotter it'll act differently too, like because right now it's in the winter. So anyways, but these are very low friction wheels, like as you see, each individual wheel, obviously it's empty, but they're not even, and they're thin. So I was thinking of having this trailer behind like an ATV. And yeah, it's super eco-friendly because obviously it's an old electrical panel. That's the thing. These 3D prints, the file was originally like smaller, presumably for like RC or whatever. I scaled these up to 180%, so it's 1.8 times the regular size. And the thing about 3D printing is the bigger you go, it's like exponentially more filament, like because it's all directions. So it's not just like twice as much filament as the original file. If you make them twice as big, it's like 4 times or whatever the You know what I mean? And that's the same reason why humans and animals and stuff are limited to their size, because as we get bigger, we'd get exponentially heavier and stuff, and that's, you know what I mean? So that's why dinosaurs weren't like infinitely big, but whales and shit can be super big, just how they kind of go. Now, the axle, it's just thread rod. I printed, I basically tried to mimic the kind of idea of like almost like a suspension. So the thread rod goes through the center, like, if you know what I mean. So the thread rod goes through the center, and the center is floating. So if you hit a massive bump and this axle wants to go towards the bottom of the trailer really hard, I have a large gap in the bottom, and this is TPU. So it's the same material as the tires. It's just very flexible filament, and I made it quite like I did it like solid, so it is very stiff, as you can tell from the tires. I wasn't thinking the tires were going to be that strong. I didn't do any math to figure that out, but the tires are actually way stronger than I was expecting. They don't flex that much, so we'll see how it feels riding. But the dual walking beam suspension, it's very smooth naturally. That's the thing. And where I put the kind of shock here, I'm not sure how well it's going to retain, because I just did like a U-bolt and then a flat bracket on the bottom there. You just buy it at home, hardware, whatever. Same thing as the thread rod itself and the nuts and the washers. I just use like stainless steel washers and stainless steel nuts where I could, just so it doesn't rust too bad. But I'll probably have to pour 15 or some sort of heavy treatment, because it's probably going to rust to shit here too, obviously. But yeah, obviously no provisions for brakes. That's probably maybe a thing we could look at. Just put like a block, boom, stop this here. But whatever, honestly not a big deal. So this is probably behind like a four-wheeler, or even like a robot or something like that, because I proofed the size of this box a little bit before I did all this, and I can actually fit a small, like, you know, those like 1200 watt generators or whatever. You could fit a full-on generator in here, and you can fit a full-on like large jerry can, whatever you call it, like it just barely squeezes in. And it would actually fit with the generator. So theoretically, you could haul like, you know, that, and maybe you could put some like camping gear, whatever. Depending, I'll test to see how strong this is, but I used really thick metal for the beams because of right here. You know what I mean? Because I had to drill such a large hole through the steel, with the step bit and everything. But there's a lot less meat there in this one portion. So that's the only thing about these that kind of is a limitation. And then obviously the thread rod, and I'll see how long, you know, how well the actual panel, you know, the body takes it. But these panels are quite thick steel. Like, this is not a breaker panel, this is actually a fuse box. So fuse box, quite thick steel. So I think it's going to be good.